Okay, this is lecture 4, a continuation of grading retention systems. These are the subjects we're going to cover in this lecture. You will want to come back and look at these as you're working on the projects. First off, an overflow design, a typical trench drain design, and then 3 systems that you are likely to use: trench drain across the sidewalk, a drop inlet with no raised drop inlet, and a seating wall retention in a plaza. So we're going to start here with a typical overflow design. This is something that you will probably use in your bus turnaround or your car turnaround and drop-off area. The basic idea here is that there is overflow from this system. That is, water is going to run into the system. It's going to run in on both sides. The curb cuts will have to be at the same elevation. The system is then going to fill up with water, and then it's simply going to overflow down to the next area that has a drain. So again, we have water coming down and hitting the system, and after it does that, it's going to flow around the edge of the curb until it finds an opening. Once it finds that opening, it's going to go into the system. That opening is going to consist of curb cuts. In this case, we have 2 curb cuts, and note that the elevation of those curb cuts have to be exactly the same. The system is going to fill up, of course, until it hits the berm that you have created inside your turnaround area. And you're creating that berm by having your high points clearly shown, and these high points have to be well above your curb cut elevation. In fact, you would like them to be half a foot, if possible, above your curb cut elevation. So again, water flows down, it flows into the system, it starts to fill up the system because you've created a berm down here that keeps it from overflowing downhill. So you might be asking immediately, well, how is it that we get away with not having a raised drop inlet in this system? And the answer is that it's simply not needed. Water flows into the system, flows in on both sides, fills up, and then once it's filled up, water backs all the way up to the curb cuts that are on each side, and then it basically blocks the curb cuts. So the remainder of water simply passes around the system and continues on down on the pavement. So this actually makes a very simple system because we have another curb cut down here. So all that water can simply come through that curb cut. And just like some other curb cuts that you've got a raised drop inlet right after that curb cut. So again, the whole system functions, and there is no need to have an RDI in the turnaround. Your RDI can simply be down here at the bottom of your system. So the pieces that you need to make this work are just like the system we've already have shown you. You're going to have some sort of a closed contour that holds the water. You're going to have curb cuts. In this case, if you have more than one, they must be at the same elevation. You're going to have 2 contours that create that berm, and then you're going to have high points between those berms, and then the whole system is going to flow down to the next curb cut, and you'll have another raised drop inlet at the bottom where all this water is going to flow. So in terms of the details for the elevation, let's make sure we understand. Again, these curb cuts must be at the exact same elevation. And the reason is, if they're not at the same elevation, water will simply flow out of one of the curb cuts. You have to designate the low points within the system. You have to designate the high points that make up the berm. Again, you'd like those to be at least at least a half a foot above the curb cuts. There's obviously the berm that's created by those high points. And then the elevation of the curb cut down here is independent of the turnaround. It's based upon the parking lot as the water continues to run down around this system after it's filled and runs into that curb cut. So the second design you're going to commonly use is one that has a trench drain. And the reason for a trench drain is it allows you to redirect water or to subdivide your drainage areas into smaller areas. So if we did not have a trench drain, this area at the bottom is going to have to handle all of this water. But because we have a trench drain, we can take half of this area and divert it down to another retention area. This is something you're going to use in your entry court plazas and possibly in your parking lots as well if necessary, but mostly in your entry court plazas in order to break the drainage areas into smaller sub-drainage areas. So again, we have faded out the drawing and we're going to show you exactly how this works. And as I said to begin with, we've got water just sheeting off of this paving area, and we're getting a large quantity of water down at the bottom. However, once we add this trench drain, now we have a large amount of water that's being diverted into this system, and the rest of this water can run down separately into another system. So what we've basically done is we have said that we're going to break this into two sections. We have one drainage area here, and we have another drainage area there. This is going to make it much easier for you to maintain small retention areas. So once we have this water diverted, it's going to start to fill up the retention area that you have designed down at the end. Once again, you're going to create a berm that keeps that system from overflowing downhill. As a result, you're going to have a smaller amount of water on the backside of the drain or the downside of the trench drain that can then be diverted again into a smaller retention area. The pieces that you need to make this work are pretty much the same as before, with only the addition of the trench drain itself. Once you have that, of course, you're going to have your closed contour that shows where the water is going to be held. You're going to have the two contours, in this case the 1106 and 1106. You're going to create the berm in between, and of course you can also include a raised drop inlet inside this system so that the water does not flow over the berm, and when it gets up to the capacity of this system, the water simply flows into the raised drop inlet. And please remember, just like before, that raised drop inlet has to be lower than the berm, and in fact you want it to be at least a half a foot below the berm. So here are the spots you need. You've got the trench drain. You'll need to have elevations on the surface for that trench drain. You do not need to have the elevations for the pipe. You'll need to have the elevation for the low points, as we've done before. You need to have the elevation for the high points that then create the berm that goes around. And you'll need to have the elevation for the raised drop inlet. So these are the same pieces that you've seen in previous designs. The only difference is that we've added in this trench drain that then diverts water down into a smaller retention area. So now we want to talk about three typical designs that you're going to be using, three typical systems that you're probably going to need to understand how they work in order to complete this exercise. So our first one is a trench drain that runs across the sidewalk. This basically is the same as a long curb cut, if you will. So if you have a curb cut and you want to get it through a curb, that's one thing. But if you've got a sidewalk, you need that longer distance. So what we do is that we actually have then the curb cut up here, and we simply draw the lines that extend it through, and that becomes a trench drain. And of course, this curb cut has to be in front of the raised drop inlet. So our curb cut will be right here, and then our raised drop inlet is going to be right after that. And the reason is that we want the water, once this fills up with the dirty water, we want the clean water to flow into the... So to begin with, we've got water flowing down, and that water is then going to be diverted because of the curb towards the curb cut that also becomes the trench drain. So that water simply runs down through the curb cut, through the trench drain, into the retention system. After it runs down into the system of course starts to fill up until it has reached its capacity. Once again, you're going to create a berm on the back side. That berm is going to be between two contours. In this case, they are still the 1106. Always remember, those two contours have to be the same elevation. And of course, one of those contours could be the closed contour that designates your retention area. And again, we have the two contours at the same elevation and the spot elevations that give us the berm in between. Both of these contours are at 1106. And of course, we have our raised drop inlet, or RDI. It has to be lower than the berm. And if I ask you how much lower, you know it's at least 0.5 below the berm. And so for the elevations, you should be getting used to this now. You have your curb cut elevation. You simply want to label your trench drain. You want to have your high points. You want to have your raised drop inlet, and you want to have your low points that spread water out throughout the system. So the next thing we want to talk about is the idea of doing a drop inlet that has no raised drop inlet. So it would not be unusual to have a drop inlet in the corner of your parking lot. Above that drop inlet, you're going to have two curb cuts, just barely uphill from it. And again, they must have the same elevation because this is all draining down into one bioretention system. So we need to emphasize again, the curb cuts have to have the same elevation. We of course then can have a trench drain that's connected to one of those curb cuts. That gets the water all the way across the sidewalk. So water flows down into the system. The system starts to fill up until eventually it blocks off the curb cuts. Should be familiar by now. You're going to have a berm between two contours that keeps water from overflowing. In this case, the two contours are 1107. Both of them have to be the same, with the berm in between. We'll have spot elevations to show the top of the berm to keep the water from overflowing the system. Your drop inlet elevation is going to be determined by the parking lot. So just like your curb cuts were determined by the parking lot, your drop inlet elevation will be determined by the parking lot. And because that drop inlet is just slightly downhill from the curb cuts, its elevation will be just slightly below the elevation of the curb cuts. So again, if we ask you what's the elevation of the drop inlet in the parking lot, it is determined and can only be determined by the elevation of the curb that is in the parking lot. Then of course we have the question of what's the elevation for the berm over here. And you already know it's going to be a half a foot above the curb cuts in this case. So the curb cuts right here have to be half a foot below the elevation of this berm, because what will happen then is as water flows into the system is going to fill up, and once the system is filled up, these curb cuts become blocked off, and the rest of the water has to go to the drain. And that water is the cleaner water that comes later in the storm, and it's released downstream. And again, you're going to want to refer back to this drawing to get all this information. So here are the curb cuts. We only have one spot elevation and two little leaders that tells us that those curb cuts are at the same elevation. We have the trench drain labeled. We have the low points labeled. We have the high points labeled. And of course, we have the elevation for the drop inlet. And I want you to note when we look at that, the elevation for the drop inlet is the same as the elevation for the bottom of curb. The elevation for the drop inlet will always be the same as the elevation for the bottom of the curb. This is not true for raised drop inlets, but it is true for the drop inlets. And the final one we want to show you is seating wall in a retention plaza. This is going to be very useful if you want to break up your plaza into smaller drainage areas, hold some of that water in the drainage area by creating a sunken bioretention system. And when you're doing that, it also could be very useful to just put a seating wall around the downhill side of that retention area. Do not put it on the uphill side, because if you put it on the uphill side, the water will not go into the retention area. So again, you can create a sunken retention area. And if you want to put a seating wall around it, you can do that on the downhill side of the retention area. So here we have our retention area. Water is running from it in two different directions. And then here we have a seating wall that's running around the downhill side of that retention. Again, water is running into the retention area. It's running from both sides. There's no seating wall on the uphill side, so water can simply flow right in. As that water flows in, then of course this retention area will fill up with stormwater. And so in this case, the seating wall actually becomes the berm that keeps water from overflowing out of the system. We still have our two contours, although they might be a little less obvious. One of them is fairly obvious. The other one is actually running along the edge of the seating wall. That one may not appear in your drawing as a contour. It may simply appear as spot elevations. And of course, we have a raised drop inlet. Again, that raised drop inlet is at the upper side of the retention area, so that the water that comes after the first flush is captured, the water that continues to come is diverted into that raised drop inlet and is allowed to flow downstream. So if we look at the spot elevations, we have a similar sort of thing. Obviously, there's no curb cut here because water is simply sheet flowing into the system from both sides. In terms of spot elevations, we're going to have the low points that are in the system. We're going to have a high point that is related to the bench. We're going to have the top of the bench itself. And of course, we're going to have the raised drop inlet. And the raised drop inlet, again, needs to be lower than the high point. Could be that we can actually sink this bioretention area down further, because by sinking that bioretention area down further, it makes it easier to make sure that that raised drop inlet is half a foot below the high point. So it's not unusual to simply have the edge of the bioretention area have a vertical wall that's about a foot deep or so. So these are the basic techniques that you're going to use on your plan. And of course, we provided you with a few other plans you can take a look at. And you might discover that under different circumstances, you might want to take this plaza area, break it up. Maybe you're going to have a trench drain that runs water over to one side. We've already talked about how you might have an overflow system around the drop-offs, and how you might have a drop inlet at the corner with two curb cuts on each side that allows water to flow into your retention area. So these are the basic methods for making offline systems. Remember, all of these systems are going to have some sort of under drain, but what you do not want to be doing is online systems. For this course, we're simply not going to allow any online bioretention systems. So this is our fourth lecture. We broke grading retention systems into two separate lectures. So for this one, there's a number 3 and there's a number 4. You'll want to go back and take a look at all of these. Don't be afraid to go through the slides, use them as reference material, and ask questions of us as you move forward in this process.